Alright, you guys, number five. I think number five is pretty hard. So put on your seatbelt and, good luck. We have that Mosaic Industries is an international company that sells cell phone cases. Their market research predicts the average number of cases they will sell each month is modeled by the equation blah, okay, where X represents the selling price and euro for each case. And N, of course, is going to be the average number of cases. And so let's first understand that N is going to sort of be like number of cases, and X is going to be the selling price. So for part A, we have that a salesperson suggests that Mosaic Industries should sell the cases for 60 euros each. And so clearly this is going to be an X value, okay? We need to find the average number of cases, so you need to find an N for part A. You need to find an N that this model predicts Mosaic Industries will sell at this price. And so pretty straightforward for part 5A. This exercise is still relatively friendly. For part 5A, you need to plug in on your function N, you're going to plug in an X of 16. So in other words, you will be asking your function at this point, when X is 16, what is N? When each case is sold at 16 euros each, what is the number of cases that get sold? So N equals the 20,000 minus 1,000 times 16, right? And if you plug all of this into your calculator, you're going to see that 20,000, whoops, you see that 20,000 minus 1,000 times 16 gives you 4,000. So N equals 4,000, all right? So 5A, we're going to say that at this price of 16 euros each, N equals 4,000. And for part B, we're going to calculate Mosaic Industries' average monthly income before expenses at this selling price. And so monthly income is a little bit like money earned, okay? And so money earned is just going to be each phone, each phone is being sold at what price? At 16. And how many phones are you selling? 4,000. And so for part B, all you need to do is take the amount of phones that you have, multiply it by the price that you're selling them, and that will be your average monthly income. Now I'm sure that some of you econ nerds out there might be thinking, okay, but there's a cost associated to this. And I say you are absolutely correct, but this exercise still doesn't get nasty. We are still before any expenses. And so all you need to do is just take the brute amount of cell phones, multiply it by the price that they give you, and that will be your profit, or better said, your monthly income for now. Profit includes costs, so for now it's just income, right? So your income is going to be the amount of cell phones, 4,000, times the price that you sell it at, 16, and there it is. So your average monthly income for part B will be 64,000, all right? Now let's recall that all of this is in euros, all right? And then part C, they tell us that hence, so because it's hence, you need to use everything from before, so that's good. Write down the function Rx. Okay, that sounds horrible. Write down the function Rx that can be used to predict Mosaic Industries' average monthly income before expenses at any selling price X. Now notice, technically what they're saying is like, okay, so what you did for part A and part B, give me a function that I can always use. So what did we use for part A and part B? On the one hand, you found an amount with n, and then you multiplied it by the amount of, by like the price and the amount of stuff that you had, like etc., right? And so all I really did, all I really did was that this n, okay, this n, I multiplied it by my price. Okay, technically I found an n of 4,000, and then this n of 4,000, I multiplied it by my price, correct? So technically, Rx is just going to be your price X times your amount N, right? But N, okay, N we said was this. And so really, Rx is going to be X times 20,000 minus 1000x. And why do you need to leave it like this? Because they want it to be in terms of x, right? They want you to write down the function r of x at any selling price x. So you only need x. You do not care about n. But n is technically like this whole thing here, right? Like, whoops, my computer just went crazy. So technically this n here is this whole thing, right? And so you plugged it in just to have it all in terms of x. This is one way to answer. This gives you the point, okay? Maybe for you it's more friendly if you distribute the x right away. Maybe down the line for you makes more sense. You can also write r of x as 20,000 x minus 1,000 x squared, okay? So both of these work, to each their own. That is for part C. Now it starts getting a little bit more nasty. Now it's the part where you say, okay, yeah, paper 2 is crazy, like, what is going on? And so here they start telling us, okay, here they start telling us that Mosaic Industries has 10,000 euros of fixed operational monthly costs. Additionally, Mosaic Industries must pay their phone case supplier 10 euros for each case. And so when you calculate Mosaic Industries' average monthly profit, so notice how now we're talking about profit and not income like before. Now we're talking about profit if they sell each case at price of 16 euros. So guys, unfortunately, you do need to know the following detail. Income is like before costs. Profit is after costs. So it's very easy to have a positive income, but sometimes it's very hard, to have positive profit. And so profit, you need to acknowledge these costs. And they tell you that on the one hand, there's a fixed monthly of 10,000. And on the other hand, you need to pay your case supplier 10 euros for each case. And so you need to express all of that, okay, for part D. And so one way to do this, which I think is the most friendly one, is that you can do your income minus your costs, which gives you your profit. Okay? And so I already have a function for income from part C. And so income, I can already call it, there's not a lot of space here, but whatever, I can do it up here. So we have, sorry, you have income minus costs will give you your profit. And I already know from part C that I have a function for income, r of x, right? And your costs, I'll do them at the end. Okay, so for now, let's just focus on plugging in rx correctly for now, right? Now, because we're still selling at 16 euros, I will be looking at R16. Okay, it's going to be your income when you sell it at 16 per phone. And so Rx from part C, we said it was this, correct? So technically, I can put up here an X parentheses 20,000 minus 1,000 X. And all of this, I still don't do minus costs to get your profit, okay? So if I now I'm going to focus on plugging in for costs. See? So this right here is just going to be my income on the left side. And now for costs, well, on the one hand, you have 10,000 of fixed monthly, right? Now careful. All of this is in monthly. So all of this is in monthly terms. It's not that you need to multiply by 12. It's not that they're asking for how much you earn per year. All of this is in monthly, okay? And so think about it as just a fixed operational cost, okay? The word monthly here doesn't really matter, okay? Each month, it's filled with monthly. So it's all in terms of monthly. Don't be scared by the word monthly. Basically, one of the costs you have is a straight up amount of 10,000, period. So straight up, one of your costs is 10,000. And your other cost, which is why I'm going to be doing it negative, because you're subtracting from your income, you're losing money. So one of them is this fixed 10,000. So I'm going to actually put up here just so we don't forget. So this is fixed. This right here is just income, this whole thing. And the other one we need to do is the per case. So they tell you that they must pay their phone supplier 10 euros for each case. So technically, here I can put, you pay 10 per case, 10 times n. And so this will be your, if I get very fancy, it's variable, right? So it's your variable cost, because it's what changes. But for us, to keep it clean, to keep it more friendly, we're just going to put per phone. Per phone cost. Okay, so here I have fixed cost, over there I have per phone cost, and over there I have income. So now it makes a little bit more sense to work with this. All right, guys, earlier we said that we wanted to have it all in terms of x and not n. What did we say n was? We said that n was this. And so now my income, well, stays the same. Your fixed cost is literally right there. And your per phone case is 10 times n. N being 20,000 minus 1,000x. So all of this is your profit. All right. And now what is your x value? Well, here, and actually just to leave it very clear, so this whole thing on the left is income. So all of this is income. This is the fixed cost. And this last part is the per phone cost. So now if I plug everything in with a certain x value, I get the profit at that level. And so from here, what is my x, right? Well, x, we are saying in this context that x is your selling price. So you have selling price x. What price are you selling? At 16. That's why at some point it said that your r has to be 16. Now technically, everything is 16 because x equals 16. So you plug in x equals 16 for everything, so you end up with 16 times 2,000 minus 1,000 times 16 minus 10,000, which is your fixed cost, minus 10 times 20,000 minus 1,000 times 16. Now, I know some of you are looking at this saying, dude, this is crazy. This is such a long equation that is so annoying. But if you take it piece by piece and you start thinking about, okay, on the one hand, I have income. On the other one, I have my costs. It's a lot easier to face, okay? So go piece by piece. You might end up with like a crazy long equation, but if you follow the process, it's fine. And all of this, ladies and gentlemen, comes from this first line. Okay, so this first line, income minus costs equals profit, is key to make this a little friendlier. All right, and I've actually noticed that there's quite a few exercises that tend to show up that talk about profit, talk about income, talk about costs, so might as well get to learn it a little bit. Income minus costs equals profit, period. Start from there, follow through, it'll work. So all of this I can plug into my calculator. See, I could plug in piece by piece, but that is annoying. So I'm just going to plug in everything because that is how I am. So over here I can say this first parenthesis is 16 times 2,000 minus 1,000 times 16. Close parentheses, minus your fixed cost, which we said was 10,000, minus 10 times 20,000 minus 1,000 times 16. Close, close. This is the profit that I am getting for part D. Now here, I think I have something fishy going on because I just ended up with a negative value. So give me a second. I'm just going to double check what I plugged in, right? So let me double check. I don't think it makes sense that this is negative, but let's see. So here on the right side, looks clean. It's times 10 minus 10,000 looks clean. Minus 1,000 times 16, close parentheses. It also looks clean. All right, I think I just realized where I messed up. So sorry for the long, awkward pause, but I think it's good to include in the video anyways, because it's a little bit more real. If the data test you plug in and you get a negative value for profit, it can be correct because maybe the guy is putting in the wrong price, and he's actually not earning money, so he shouldn't be doing it that way. But I just realized, notice here where I plugged in for n, right? So here I plugged in for n, so all of this is n, all of this is n. Careful, for n, right, this is 20,000. So how come I have 2,000 here? Because this was for income. And so for income, there it is. For income, small detail, but here I have 4 zeros, and here I passed on to 3. So there I trolled a little bit. I missed a 0 here, I missed a 0 here, I missed a 0 here. And now my numbers should make a little bit more sense. So let me plug it in again. I'm keeping it in the video because I think it's amazing when you guys see where I commit a mistake. Because we all make mistakes. It is nothing to be ashamed of. And it also shows that if you ever get an answer that's a little bit weird, take a moment, double check. Take a moment, double check, and might as well, right? And so I double checked. I realized I was missing a 0. If you realized earlier, nice. If you didn't, don't worry. There it is. This makes a little bit more sense. It's a positive value, so I'm going to trust it a little bit more. I'm glad I checked because clearly I was missing a 0 for the income. See? So anyways, that is for part D. So for part D, you would say that the profit equals 14,000 euro. All right, so that is for part D. Now for part E, we're going to show that the average monthly profit for any selling price, X, can be found using the function blah, blah, blah. Now, this is for profit, right? And technically, I also have an equation for profit. And so this line here is where I plugged in for profit with an x equals 16. And so we need to show that this right here, which is an equation for profit, is also what they have down here with negative 1,000 x squared plus 30,000 x minus 210,000, right? And so from our equation of profit, we need to reach this equation of profit. Why is that my approach? Because it's a show that exercise. Whenever you have a show that exercise, this is true. This is the profit equation as it should be if you boil it down a lot, right? If you like work through it a lot, etc., right? And so up here is like my profit function, but it's not yet developed like fully, right? And so if I develop it fully, I should reach what we have in green. And so from here, let me take a moment and try to develop it fully. And so from here, you can say, for example, this, actually, let me just rewrite it. Or actually, no. So for this income, I'm gonna distribute the x, right? So if I distribute the x for income, I will have 20,000 x minus 1,000 x squared. So this is my first parentheses. See? For this second one, I have fixed cost, which is not gonna change. It's just gonna stay there. And for this last parentheses, I have this times this and this times this. So 10 times 20,000 should give you 200,000. But just so you trust me, because I am a guy on the internet, and you shouldn't trust guys on the internet, here it says 200,000. So I have minus 200,000. So that was this jump here, okay? And then minus 10 times negative 1,000 should be 10,000, but let's check. All right, and here I have plus 10,000x, right? Why is it plus 10,000 and not negative? It's plus because here you're multiplying by negative 10 times a negative 1,000 here. And because I'm a boomer and I didn't realize, there is a times 16 going around here and here. So yet another mistake for you guys to look and laugh at. So technically, this first number here should have been or actually, wait, I'm trolling. Wait, I'm trolling. That 16 was when we plugged in x equals 16. No, I'm fine. I haven't said anything. I was looking at the wrong side. I'm sorry. But still, this would be plus 10,000x because it's a negative 10 times a negative 1,000. So negative times negative gives positive. All right. Sorry, guys. I think I'm not very concentrated this week in general. But anyways, So you just distributed x and you want to reach what's in green, right? Now what's in green is all nice together and combined and etc. So we're going to do that now. For example, I can combine, let's focus just on x squared for now, right? So just x squared is only this one. So I'm going to leave x squared up in front for now, all right? So I'm going to leave x squared up in front for now, all nice and alone. And later on, right, oops, and now, later on, I can now combine the x's, right? So I can combine, for example, this x and this x. And so you're going to have 20,000 plus 10,000x plus 30,000x. And last but not least, you can combine these two. So you can do the negative 200,000 minus 10,000. So that gives you minus 210,000. And from here, I can check if I got the same thing that's in green, and it looks exactly the same. And so for the show that, for part E, the show that, like strictly speaking, for part E is going to be what I am putting now in yellow. So for part E, it's technically all of this. This is part E. Okay, that is part E. So this is for showing your work for part E. This is part E. Okay. Anyways, we ended up reaching the same sort of equation. So that is what we will be using for profit. So that is for part E. We check it. Part F, immediately, we see that it has two parts. And whenever it has two parts like this, it means that the second one depends a lot on the first one. Okay, a lot of times, I don't know, part E needs something from part F and stuff like that. It's not always the case, but it is always going to be the case that part 1 is needed for part 2. All right, so that is already a big hint for what's coming in front of us. And here for part F, part I, part 1, we have find the derivative of px. And so how do I know it's the derivative? It's because you have this symbol. And any of you that just thought, isn't that the inverse? Inverse would be if they write it like this. Derivative is if they write it like this. Okay, so it's the difference. Here you have a -1. Here, technically, it's like an apostrophe. Okay, so this one is going to be for the derivative, and this one is going to be for the inverse. All right, so there's a small difference there. Know your differences. All right, you guys. So the derivative for the IBA ISL level, if I put it into my formula booklet, you have this one, which is the derivative of the exponent. So you can look it up. I actually have a video on it. You can enjoy your time there. There's a bunch of other derivatives, but this is for HL, so we can just, laugh at them. Anyways, we only care about derivative of an exponent. And so here, I know it looks a little bit weird, but really, really focus on what n is doing. So n, first of all, multiplies in front, and second of all, it gets a -1. In other words, x squared is going to be 2x, because it went in front, and then 2 minus 1 up top. Derivative of x squared is just going to be 2x to the power of 1, which you leave it as 2x. But mister, what happens if there's a fraction? What happens if there's a number in front? 3x squared is going to be 3 times 2 times x to the power of 2 minus 1. So it's going to be 6x to the power of 1, the same as just 6x. What if there's a fraction or whatever and blah, blah, blah? Okay, 1 over 4 times x to the power of 8. Let's go crazy, to the power of 8. So derivative of this is 1 over 4 times 8 times x to the power of 8 minus 1. And so from here, you're going to have 8 over 4 for the fraction times x to the power of 7. 8 over 4 is the same as 2. Derivative of this is that. All right. There's a lot more examples or better examples in the video that I have for derivative of an exponent. But for our intents and purposes, from here, if you do derivative of p of x, well, this first term, right, you're going to have negative 1,000 times 2 times x to the power of 2 minus 1. For this next one, you're going to have 30,000 times 1, because technically x to the power of 1, the 1 has to go down, right? Times 1 times x, that was a nice voice crack, times x to the power of 1 minus 1. And this last one is technically 10,000. If I get very, very technical, it's going to be 10,000 times 0. Because here you have an x to the power of 0. And so I'm just going to leave it at that, right? X to the power of 0 times x to the power of 0 minus 1. If you get very technical, here there's a hidden x to the power of 0. And so this whole thing is being multiplied by 0. So this last term goes away. All right. The other way you can learn it is that if there's ever a term without an x next to it, whenever you do the derivative, it just kind of disappears. So this last term is going to disappear. And from here, what you end up with is, well, you end up with derivative p of x is going to be this 10,000 times 2, so it's going to be negative 20,000. 2,000, not 20,000, sorry. I'm definitely a little bit not too concentrated today. So negative 2,000 x plus this 3,000 that you see here, plus 30,000, sorry, plus 30,000. And because you had x to the power of 1 minus 1, you end up with x to the power of 0. And anything to the power of 0 is just going to be 1. So it's 30,000 times 1. That is your derivative in this case. So remember, guys, anything to the power of 0 equals 1. This is just a mathematical rule. I've explained it a couple times, but just very quickly, if you have, I don't know, 2 to the power of 3, it's going to be 8. 2 to the power of 2, it's going to be 4. 2 to the power of 1, it's going to be 2. 2 to the power of 0, as I said, is always going to be 1. Now, if you go in this direction, you're doing times 2. You're doing times 2. But if you work backwards, you're going to end up doing divided by 2. Divided by 2. And 2 divided by 2, one last time, gives you 1. So anything to the power of 0 equals 1, because eventually you will inevitably reach itself being divided by itself, which will always equal 1. That is why anything to the power of 0 equals 1. I think there's like a couple other ways to like prove it, but that is my favorite. So all that blah blah was all of us to agree that for part F, part I, this is the answer. And then for part AA, you need to show that the salesperson's selling price does not maximize their average monthly profit. Interesting. Does not maximize. Does not maximize. So whenever you have a problem that talks about maximizing, optimizing, finding a maximum, finding a minimum, you can immediately consider doing derivative equals 0. Okay? And why would we want to do derivative equals 0? Because, ladies and gentlemen, imagine you have like, I don't know, like a parabola like this, okay? So this is x, this is y. When you have the original function, for example, just a normal like f of x, you plug in x, you get a y, you get a bunch of points, right? You plug in x, you get a y. But the moment you have the function in its derivative form, you plug in x, and you get a slope. And so basically, when you have a derivative, the x that you plug in, you're asking your function at an x of, I don't know, 2, what is the slope? Instead, over here, if you plug in an x of 2, you're saying, when x is 2, what is y? And that gives you a set of points. This other one, technically, it's also a set of points, but the y is now slope. See? So I said that you want to do a derivative equals 0, which is the same as saying that the slope equals 0. So why would you want a slope equals 0 to find the maximum, minimum, and all that stuff? Well, think about it. So let's focus on this parabola here. At this point over there, which we will call x equals negative 1. So at x equals negative 1, what do you think is the slope? Well, immediately you should be thinking the slope, is it positive or negative? The slope is positive because it's going up. So here you have a positive slope, right? Let's say that it's going to be positive 3. I'm just going to make it up. I don't care. Deal with it. So this is a slope of positive 3. If you keep going, for example, right next to it, this is still a positive slope, but it's a little bit less. We're going to call it positive slope of 2. And if you keep going, eventually this is, I don't know, positive 1, right? And right at the maximum, right at the point of optimization, right at the vertex, wablam, wablam, you have a slope of 0. So wherever, and this is a massive idea, you guys, whenever you have a slope of 0, you have a max or min. It is a rule that always applies. Even if you have a parabola that goes like this, if you keep calculating all these slopes, so this is, I don't know, -3, then this is -2, this is -1, eventually, this is a slope of 0. So if you do the derivative and you equal it to 0, which you said this, is for finding the slope of 0. And so from there, you find the x value. This is a fascinating thing. From here, you find the x value of the vertex. So here you find the x value where the slope is 0. That is the main idea. When you do derivative equals 0, you are finding, whoops, that would have looked really weird. You are finding the x where slope equals 0. So finding the x where my function is optimized, which can be at a minimum, it can be at a maximum, but those are the points of optimization. And so if you take this derivative here and you equal it to 0, you literally already gain a point. That is already a way for you to get a method point by saying that this equals 0. Okay, and if this equals 0, basically what you're saying is that 0 equals -2000 x plus 30,000. And how do you get x from here? Well, you can say plus 2000x plus 2000x. So 2000x equals 30,000. You divide by 2000. You divide by 2000 to get x alone. X has to equal, quick maths, 15. So at x equals 15 is your maximum. And so here we are showing that the salesperson's selling price does not maximize their average monthly profit, because to maximize their average monthly profit, it is exactly at x equals 15, and over here they are selling at 16. And you might be thinking, wouldn't a better price be like more expensive because then you earn more? And that's when all your econ guys say, nah, because of elasticities. And I'm not going to get into that because this is a math video, not an econ video, but intuitively I'm going to tell you that if something is way too expensive, a lot of people will stop buying it. But if it's a little bit more expensive or a little bit cheaper, you might end up with a lot more people buying you. A simple example, let's say you're selling sandwiches, right? And you can choose between selling the sandwich at 10 euros or 20 euros. At 20 euros, you are selling less sandwiches, but they are more expensive. At 10 euros, you're selling a lot more sandwiches, but it's also a lot cheaper. And so which one gets you more money? It depends on how your consumers behave, okay? And so in this case, the maximum is actually right at 15 instead of 16, okay? And if you want to get very, very nerdy with this, you can go to Desmos, graph it in your graphing calculator. But just so you guys see, and just so you guys finish getting convinced, if I graph my original function, so my original function is p of x equals negative 1,000 x squared plus 30,000x, that's 30,000, right? Yes. Minus 210,000, we found that our optimum is at x equals 15. And so if I zoom out, and here is my, well, I gotta go all the way up because we're talking about big, big values here, but okay, this graph is definitely not friendly. Let me do it in my graphing calculator, see? Usually Desmos is good for like doing it quickly, but in this case, seems like not so much. So just so you guys finish getting convinced, 210,000. I'm going to change my window a little bit, so I'm going to say x is 0. My max is going to be 30 because at x equals 15 is my max, right? And my y max is probably going to end up being really, really big values. I'm just going to put like whatever, let's work from here for now. So we're going to graph this. All right, clearly my y value is like insanely big. So I'm going to cut down on 2 zeros maybe. Okay, now it's not enough. I'm going to add 1 0 now. It's still too big, but we're closer. All right, whatever. Let's just go back to the original point. I'm just trying to explain that your maximum has to be, if you do calc max. Okay, this is just to show the idea. This is not part of the exercise. So you do left bound here, right bound here to find your maximum. Your maximum is right at 15. I mean 14.999, whatever. You take that as 15. So right at x equals 15, you have your maximum. And how did you figure out that that value was your maximum? Because we did derivative equals 0. We found that x equals 15. And so at x equals 15, you have your maximum. At 16, you're not at your maximum. You're actually earning a little bit less. Okay? In fact, if you use trace a little bit to the right for 16, you're earning less. Here you're earning around 13,000. While out of 15, you're earning 15,000. So it's a small difference between 15,000 and 13,000, but companies care about money, and to be honest, so should us. Maybe not as greedy, but that's another topic for another day. Anyways, you guys, that is for part F, part double I. Alright, you guys, and now for this last part, we have that Mosaic Industries negotiates a new deal with their phone case supplier. Under the new deal, the supplier agrees to discount the cost of each case based on the number of cases purchased by Mosaic Industries. And so, careful, here it says that the cost charged by supplier for each case can be found using the function blah. Okay, so this is the new cost charged for each case, where n represents the number of cases sold by Mosaic Industries. And through this, we need to find the function that can be used to find Mosaic Industries' average monthly profit using the new deal from the supplier. And so this is actually fairly easy, but you really need to be organized in your approach. And so I'm going to scroll up, and well, I had to rewrite it because I'm recording again. But basically, originally, if you go back in the video, we talked about how we found the income using this part here. So this would be the income. And we talked about how this here was the fixed cost. All right. And we also talked about this here is the cost per phone. And so at some point, there are two things that happen. At some point, we said that n was this, which makes complete sense because we're talking about this n here. And at some other point in time, we said that this n, the cost per phone is 10 times n. And it's 10 times n because this 10, which is the same as this 10 here, is the same as this 10 right here. And so Mosaic Industries per phone had to pay 10 euros. And so what's happening now in part G is that now they don't charge them 10 euros per each case, they charge them this. And you might be telling me, okay, but that's not an actual number. That's not like that they're charging 8 or they're charging 9. And I say, I fully agree with you. Now what they charge depends on the amount of phones that they buy, which makes sense, right? I mean, a classic is that, I don't know, if you buy 10,000 bottles of wine, it's cheaper than if you buy 100 per bottle because they give you like discounts for making such a large order and stuff like that. And so that is what's happening in part G. Okay, so basically this thing that I highlighted in pink, I mean put in circle in pink, is like it's your 10. Okay, so this used to be 10, right? And now technically your equation is going to end up as x times 20,000 minus 1,000x. So your income is still the same. Your fixed cost is still the same. But over here, technically, you have the cost per phone and the amount of phones. And so if you go ahead and plug all of this in pink is from part G. So this guy here. And this in blue, the n, is still the n from here. All right. So you've plugged all of that in. Technically, your equation is now, well, this is not going to change, right? I make sure I have the right amount of zeros. All right. Minus 1000x minus 10,000 minus, and here's the juicy part. So you plug in C of n. So C of n is 10 minus 0.0001. So 10 minus 0.0001 n times n, right? And we said that n was this guy times 20,000 minus 1000x. Now we're almost done, right? And the one thing that we're missing here is that how many variables do I have? The amount of variables I have, for example, in this line here, okay, which was our answer like back in the day, it only has x's. So yeah, you have an x here, an x there, and an x here. And right now, how many variables do you have? You have x, but you also have n. So yeah, you have an x, and here you have an n. And so you need to take care of this n. So what is n, you guys? Ah, n, as we've seen all along, is this. This is n. And so yes, you're going to end up with a crazy, nasty sort of equation, but trust the process and it's going to be fine. And so now I'm going to start like working with these numbers to make it look a little bit prettier. So on the one hand, I can distribute here. Okay, so on the one hand, I can end up with 20,000x minus 1,000x squared. This minus 10,000 stays the same. I'm going to put check marks just to like make sure that I've done everything, right? So minus 10,000. And here I can have minus 10 minus 0.0001 times n. And we know that n is 20,000, right? Minus 1,000x. All right, so just to be very clear, because I know that this part can be very confusing, this n got plugged into this. Now, where does that come from? From this, okay? All right, so I already did this parentheses, this part is n, and now for this last part I have 20,000 minus 1,000x. And so from here, I just need to plug in, combine stuff, basically see what happens. All right. All right, cool. So technically, yeah, this is fine. All right. And so from here, this thing on the left stays the same. Nothing to combine yet. And now in the parentheses, it gets very exciting. For the parentheses, I suggest that you first do what's inside first. So for example, first distribute from here, okay? So first I'm going to do that. So that means I'm still going to keep the minus on the outside, 10. And here I have the 0.001 times the 20,000. How much does that give me? Here I have 0.0001 times the 20,000 gives me 2. It literally gives me 2. So here I have minus 2. And then it's negative times negative, so it's plus 1,000 times the 0.0001, 0.1. So here I end up with 10 minus 2 plus 0.1x. Close parentheses. My other parentheses is still the same. So yes, these are a lot of lines of math, but as you can see, I'm just trying to take my time, trying to go slowly, do one thing at a time. So here on the left side, again, nothing's going to change. I'm not touching anything over here just yet. But this parentheses here, this first one, I can combine the 2 and the negative 2, so that gives me 8. And here I have my 8 plus 0.1x times the other parentheses. All right, and now I think I'm like 2 lines from finishing this, right? And so now what jumps out at me is that you have two parentheses next to each other. So from here, you can do the classic like, so whenever you have two parentheses next to each other, what you're sort of supposed to do is that you multiply this with this, so you end up with AC plus AD, and then you do this with this, plus BC plus BD. All right, so like everything multiplies everything. It's usually called FOIL. At least that's how I learned it. It has to do with like the first with the outer, then first with inner, then outer with last, stuff like that. See, so this is for first, outer, inner. It's just a way to remember like what most multiplies what. Okay. I don't recall 100% how it was. I just know that it's called FOIL, so you can probably Google it. Visually, this is what we're doing. Okay. So from here, everything on the left stays the same. So I'm going to rewrite it one more time. So 20,000 x minus 1,000 x squared minus 10,000. And then here you're going to have this 8 times this. So it's going to be 8 times this 20,000. So it's going to be, well, there's a minus right outside, right? So I'm going to keep that alive for now. So this negative is going to stay. So I end up with positive 160,000. And then this times this gives you negative 8,000x. And then this times this, it's going to be 20,000 times 0.1. So that gives you plus 2,000x. And then this times this should give you negative something. So it's going to be 10,000 times a negative 0.1. So that would be negative 100 x squared. Why is it x squared? It's x squared because you are doing an x times another x. See? All right, and so from here, the thing on the left still remains untouched. And I know it's annoying to rewrite it, but due the day of the test, you can just not write it until the very end. See? I just care about the parentheses. But anyways, so I go back over here, the negative still stays. I'm still working with the parentheses. And so here I can add these two together, right? So you end up with 160,000 minus 6,000x minus 100x squared. Right? And now I'm finally approaching the last lines of math. Okay? And so from here, you can distribute this negative, right? So this negative is going to change the symbols of everything. So you end up with 20,000. Oop, that looks like a big number. So 20,000x minus 1,000x squared minus 10,000. And then this symbol is going to change everything. So it's plus 160,000 plus 6,000x and plus 100x squared. And so if you combine everything from here, if you do, for example, this with this, right, you're going to end up with negative 900x squared. If you now focus on just the x's, you would be thinking like this one with this one, right? And that is going to end up being plus 26,000x. And last but not least, you can combine all of these different sort of numbers. So you have 160,000 minus 10,000, right? And so notice one small thing I missed here, and I just noticed, okay? When I distributed this negative, I should have kept this negative here. See, I mean, it would have ended up as negative, is what I'm trying to say. So small detail that I just noticed, instead of plus over here, I should have put this as minus. Okay, so we have minus 10,000, minus 160,000. Over here, end up with minus 170,000. 1, 2, 3. And so now, for part G, the function that can be used to find Mosaic Industries' average monthly profit, you can think about it as like your new P of X. So the new P of X is what I just found, which is negative 900x squared plus 26,000x minus 170,000. if you're wondering how you get these 3 points, you get 1 point for reaching this as an answer. You get a method point for doing this thing here. So this is another method point. And your last method point is just like doing this whole distribution thing over here is another method point. Okay? So there's a method point for realizing that you gotta do this step here, like this difference, right? Another method point is actually distributing and doing the math. And then getting it all correct, getting the answer is on last point. See? So I also mentioned this because, interesting. It's a lot of lines of math. You might not get it all right, but just by plugging in, just by following the process, just by doing the right method, you can get 2 out of 3. Not bad. All right, trust the method, trust the process. And now for part H. They say hence. So anytime they say hence, it's like therefore, and it's a big hint. From part G, you need to use for part H, you need something from part G. So hence, find the selling price per case that Mosaic Industries should choose in order to maximize their average monthly profit under the new deal. And so from here, I can immediately identify that like the format of my function is the format of this. And this, ladies and gentlemen, is a quadratic formula. It's a parabola, okay? And so with a parabola, if you want to find the max or minimum, in this case, we want to maximize profit, right? So the maximum, which would be the case on the left here, right? Basically, the maximum or minimum is always going to be what we call the vertex, okay? And so the vertex, this is something that actually gets asked from me a lot. It's basically like, how do you find the maximum point, right? And so you have 2 choices here, all right? One of them, and I'm just going to write it out. So one of them is that you get the derivative and you equal to 0, all right? When you find the derivative equal to 0, derivative helps for finding slopes. And so basically, for example, here you have a slope of, I don't know, 1. Here you have a slope of 1/2. And right at the vertex, surprise, right at the vertex, you have a slope of 0. And so wherever your slope is 0 is where your derivative is 0. And so doing the derivative equals to 0 helps you find the x value where your slope is 0. Where slope is 0. And that can help you find the amount of cases sold, and through that you find the selling price. Okay, so that's one choice, just doing the derivative. The other choice is that because it's at the vertex and because you know it's a quadratic, you can just find what we call the axis of symmetry. And so whatever is the x value, so x value, axis of symmetry, will give you the vertex. And so that's 2 ways to do it. You either do axis of symmetry, gives you the x value where you have the vertex, or do you do the derivative, and that also gives you the x value of the vertex. Okay, so it's 2 ways to do the same thing. I'm first going to show axis of symmetry, okay, just because I think it's a little bit more friendly, but I will show both. All right, so stick around if you want to see both ways, or just stay for this first one. So in your formal booklet, you can look up the axis of symmetry. And so the axis of symmetry, again, it's like what cuts your parabola like in half, right? The cool thing about parabolas is that they are perfectly symmetrical. That is why you have an axis of symmetry. So for example, on this point here, the distance from here to here is the same as the distance from here to here. Exactly the same. I don't know, from here to here, it's the same distance as from here to here. And so, axis of symmetry also helps you find zeros. If you know that 1, 0 is at, I don't know, -1, 0, and that your axis of symmetry is at x equals 3, then you say, yeah, so from here to here, it's 4 units. So that means from here to here, it's 4 units. Your other 0 has to be at 3 plus 4, 0, 7, 0. So, look at that. Axis of symmetry is very useful for many different things. In this case, we will use it for finding the maximum point. Okay, and so axis of symmetry gives you this line in green. Okay, it would give you the x equals 3 in the example that I gave. Now, what is the formula? It's this. It's negative b over 2a. What is b? What is a? Well, your function, your parabola, we call it ax squared plus bx plus c. And through there, so b is the one that has just an x next to it, and your a is the one that has the x squared next to it. And so if I go back here and I try to use the axis of symmetry, method, you have negative b over 2a gives you the axis of symmetry. And so in this context, a is negative 900 because of this here, and b is 26,000. All right? And just to finish the idea, c would be this. So c would be negative 170,000. We don't need c here, but I just want you to see and observe like, okay, so that is how you find a, b, and c. Okay? So if you plug into the axis of symmetry, you have negative b, which would be negative 26,000. Negative, yeah, okay. And then divided by 2a, so 2 times 900. So in other words, you have negative 26,000 divided by 1,800. All right? Now, I just noticed, dude, I am very not concentrated today. I just noticed that a is negative 900. And so here I did plug in 900, but I forgot to put a negative. So once again, I'm leaving that sort of mistakes on my video because it happens to anyone. So I should have plugged in negative 900. What is one way I realized? I realized that my axis of symmetry should be positive or else it wouldn't make sense. You can only sell a positive amount of phones. You can't sell a negative amount of phones. So that means that this over here ends up being negative. A negative and a negative makes the whole thing positive. So 26,000 divided by 1,800. Now this, in your calculator, will give me, this on my calculator is 26,000 divided by 1,800 gives me 144. So 144.444. All right. 2 times this. 26,000. All right, looks clean to me. All right, and I just realized here, oh my god, I'm gonna roll today. I put an additional 0. Sorry, guys. All right, so you end up with 14.444. So my bad. Wrote too fast on my calculator. It's been a rough week for me, guys. Sorry. So 14.444, that is what we end up with for the x value of the axis of symmetry. And so what is x in this case? Well, we know that y, we know that x is, we know that y is profit, and you know that x is selling price. And so actually from here, you don't need to find like the y value of your vertex. Just by having found that this is 14.4, you're good to go. So your final answer is 14.4 euros. If they were asking for, okay, and at this price, what is the profit? You would have to plug in, and this is just to have like a complete image of the exercise. If they were asking, okay, what is the profit, like what is the maximum profit that they get, you need to plug in this 14.4 back into your equation, okay? And why do you have to do that? Because that gives you the y value, and so that would give you the vertex, okay? That would give you the maximum. And so just to show it, this is not part of the exercise anymore, but just to show it, in case it happens to you in the future, that it's like, okay, find the maximum profit, you first find the x value of the vertex, and then you plug it in, okay? And then you plug it in order to find the profit. So the profit is 177.76, okay? So if they sell at 14.4 per phone case, their profit is this amount, and that is our maximum profit because it's the maximum point of my parabola. Ladies and gentlemen, sorry about the small mistakes at the end, but I like to leave that on the video just to show that we're all human, we all make mistakes, and check your work. Once I realized I was getting a negative value for my axis of symmetry, I said, nah, something is wrong there, and lo and behold, I forgot to plug in the negative on the 900. See? So we all make mistakes, we're all human, and if you have an intuition that something might be a little bit wrong, just double check. Take your time, just like I did, all right? Anyways, that is for number 5, and that is for the entire paper. I hope it helped.